Hello, I'm Diana Kanecki from Kanecki Art and also founder of Kanecki Associates and DKA Strategic Planning. I'd like to talk about an idea I have for making a better operating system, especially for mobile phones, Android, and tablets. Part of the reason why I went into sort of examining this concept is because um, I've started to notice that even on my smartphone, there's freezing, um, there's slow performance. And when I did research into how our smartphone applications, how they're developed, some are developed upon layers. One layer of an operating system built upon another layer. Normally it's Windows and something else, or it's Linux and Android, as I saw in one article. However, the reason why I'm concerned about this is because this goes back to a conversation I had in Chicago at one of the last Comdexes in Chicago in '99. It was a time basically my dad was and parents were still alive, and what for my dad and I, some people look at April 4, beginning of April is opening day at Wrigley Field and going to the Cubs game. For us, opening day for us was when Comdex came to Chicago in April, and in '99 it was a little bit later. It was actually in August, but it's still the same thing. It was when Comdex came to Chicago. That was our opening day. My dad would come down with me. We'd take the train down and then take a taxi over to McCormick Place and at first, when I went there, I was a little bit shy to talk with the people, vendors. I just take a literature and just walk away. And then eventually, I learned to open up and talk with people. And as my dad would, he could have conversations all forever, going on 45 minutes at a time. And when we went there, there's sometimes when my dad couldn't walk the whole show, so he'd sit down and read some literature that we picked out, and so, well, why don't you go out and mingle a little bit? And so I go out and mingle a little bit. That year, my dad wasn't able to make the train trip at all because his heart was acting up, and his beats were going down from 60 to 50, and at that time about 40 before eventually it went down to almost nothing. So I went down, took the train. And took a cab to McCormick Place. Now, if I knew what I knew then, I could have taken the CTA from the train station to McCormick Place cheaper, and because I didn't realize that they announced there are many things they'd announced the stop, and also at that time I did use public transportation, but it's only limited to the train. It wasn't the bus or anything else. And well, when I went to McCormick Place, I went there, and at one point I was walking, and I went outside just to it's a nice sunny day just to take a. And as interesting, I was previously I had met Linus Torvalds and had a chance to talk with him, and a few people from Linux Magazine at that time, and have a chance to talk with and meet with everyone in the Linux community, which was wonderful. And even some people in the ADA community. There's one young woman I met there that was with the ADA group. We had a wonderful, intelligent conversation, and it was refreshing as well. As it wasn't just all business; it was also personable too. Well, when I went out to sort of enjoy the fresh air, I had someone come up to me, and at that time I didn't have my picture really on the internet. I did have a few pictures in my internet handle was Belinda the Java girl, because I would put Java coding segments on the internet, and that was originally my handle on the internet in 1999. And what happens? He talked with me, and he and I didn't realize it, but it was the person who actually had developed Java. And he talked, and he said to me, he said, "Well, you I know you put a lot of trust in the people from Redmond." And I had to think for a minute what he meant by Redmond, and I said, "Oh, yes, Microsoft." And he said, "Well, he said, well, do you really want to put that much complete trust, and I said, well, no, I don't put complete trust, but I do, try to support things that are maintained and are open, as well as with open source. At that time, I was one of the early Slackware users since '95 of Linux, and and we went to talk, and he said, well, we'd start talking about things, and one concept that came up was the concept of the house of cards. And he said, well, are you aware, the operating systems are, or if if the people thought of them as a card, they'd still be using cable breaks and and a choke to start the car. And I said, yes, I know what you mean. For some who may not be aware of what I meant by the previous sentences, um, those of us born up to about the early '60s had of old time cars, and in old time cars, when they stopped, they actually had a cable and a pulley that stopped it. So when you pressed on the brake, it actually went through a pulley, and as a cable did mechanical advantage that they actually pushed um, the brake pad onto the wheel. So it's actually like an extended cable. The way to think of it is think of it as a 10-speed or 20-speed bicycle. There's a cable that actually shifts your gears on the bicycle, and that's how brakes were stopped. Cars were stopped, and also on bikes still use cable brakes as well. Um, the disadvantage of cable brakes was that um, when cable brakes became rusted, they'd snap due to salt corrosion or age, and the disadvantage of a choke was if someone didn't know how to set the choke properly, they could easily flood their car on the first attempt and have to wait a long time to try to restart it. So, getting back, we talked a little bit, and we said, well, and I said, yes, I realize about, and then I mentioned, so, well, what do you think about the concept of the house of cards? And he said, yes, operating systems are built as a house of cards. Like if you take a card deck and you try to build a house of cards, you put the cards together and you build it up. Eventually you can succeed, but you have to be very careful you don't blow too hard, or else they'll come right down. So we talked about this, and we talked about how there has to be something that has to be done to make operating systems better, not 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 so error prone by using rehashing old code and technology for way too long, like was mentioned, like with the cable brake analogy and the, the cable brake analogy and the choke, as well as on the house of cards. And at that time, our hope was Linux. We liked what we saw in Linux. I liked what I saw in Linux regarding the Slackware release and other flavors that came on, because even like at that time, when I started in '95 on Linux, I was at SCS dinner, and we were talking, and two of us were talking with one person who was from a major corporation, and joke was, well, he says, are you sure you want to trust a lot of slackers to write an operating system, and are you sure they'll be willing to do the work on a regular basis? Well, yes, they were, and yes, we were able to do it on a regular basis. And we did start a movement, help Linus start a movement with Linux and continue a movement with Linux. However, the problem that's resurfaced is when I use programs like Visual Studio, Embarcadero, even other RAD programs. The issue of the house of cards, the Dragon, which is a huge program, which is like it's so big that no one knows exactly what it does from end to end, and also to maintain it is becoming there's more time spending maintaining it than there is to basically making it useful for other things. And the maintaining patches are so numerous that now, instead of a program needing a small amount of memory to run, the same program needs a big amount of memory. It's like it's like a B horror movie where you have this plant and it starts out very small and very friendly, but then as it gets bigger and bigger and bigger, it gobbles up everything, and that's why I'm concerned about the layers, and also with even with the bad programs. I mean, um, the thing is, when I started, some of my early computers were actually handheld computers, which was a TI-58 SR56 for those in the programmable calculator genre, TI-99/4, Osborne 1, but my really first computer was actually a mainframe, which was a GE635, which my dad used for his work and let me use to learn BASIC. And then later, in addition to the home computer, I had TI-994 Osborne 1. Also used the PDP 1170, VAX 11750, IBM 3800 series. So it was in parallel. It was in parallel. And the Osborne one was really in the TI-994, but the Osborne one was the breaker because that allowed a portable computer to be taken anywhere, and that I could take it anywhere and do it. And when I first started working on research, I carried my Osborne one to work. This was 1989, and a friend of mine, Dr. also by name Dr. Kanecki, he carried a compact, and we were the rebels. We were the ones who didn't go strictly to the mainframe desktop. We had our own computers. We carried them with us. That's why a lot of people today see me with a laptop, because it is like when I used to carry my Osborne one. It's still 25, still about 25 pounds with my laptop bag as my Osborne one was, but battery portable and everything else. To get back to the system I was talking about. Well, with the layers, the thing is, it's become, I think, way too involved, and I think a simplification is needed. Like on many of the early computers, they didn't allow for flowery code or wasted memory because they really didn't have a lot, and the disk drives were limited. Now, what I'm showing here is an example of what's called CPM. And CPM stands for Central Programming Monitor. It was originally used by Gary Kildall. Some speculate that it eventually, various flavors went on to become other operating systems, which became very popular. But Gary Kildall worked with the Computer Chronicles for many years, and he still supported the community, even though many things have happened. But with CPM, what happened though is that you had different things. You had the bootloader, the main application memory, the central command processor, the basic disk operating system, the BIOS, and the video memory. But you also had a bank 2, which allowed, instead of having, well, this time, remember, this is a 64K computer, 64,000 bytes, not 4 billion bytes, a big difference. So what would happen is you would have part of shadow memory, which was 48K, which was 50K, or sometimes 128K. So you could actually have a program up to 200K running on a workspace that's only 64K. Now the thing about CPM though was CPM was able to be modified and to easily be patched, and also it was structured so that it could be maintained without becoming a dragon, without becoming a house of cards, and the code was updated regularly so it wasn't rehashed, so long as is today. Now, what I would propose is I'm proposing an Android and mobile operating system like I call Kanecki OS, and Kanecki OS is based upon the concept that we adopt some of the simplification that CPM has in allowing multiple applications to run, but we also have the Kanecki OS, which has a simple OS base, and also the simple OS monitor, which will allow the programs to run, share resources, Utilize some concepts from other things, including sharing of workspaces. But the thing is, though, the main point is it is to be light, light, light. Um, and what I mean by that is it's not meant to be become a dragon. It's meant to be kept compact and functional, like the way CPM was. And also, it's made to have a built-in feature so that certain central types of the operating system are not tampered with. By Because right now operating systems use different methods to allow access. The old access used to be what's called the rings. You have a ring here, you have a ring here, and the outer ring was basically every program could access and use certain services. As it gained a privilege, it could go into the next ring and use services. As it gained other privileges, it could go into the central control ring to use services. So the problem with that is this. That there are always backdoors. There are always ways that people who can get into them, people can figure out a backdoor. The point is, to stop the virus and the hacking is, I'm going to make a statement which gets me sometimes in trouble because I do put myself out on a limb and do talk about different social issues and write about social issues. But with the Kanecki OS operating system, it's gonna be a completely open system. Anyone who works on it is going to be compensated fully and fairly. Anyone who uses the operating system that doesn't compensate someone fully and fairly will have their license pulled, and we'll hear from attorneys to have a cease and desist order. So there's going to be an ethical and moral compass put in place with the Kanecki operating system. This time, no one's going to get shafted, no one's going to get played, no one's going to get used. And and what I discovered, part of the thing is it's not just the technology, it's also the culture. But like what the Linux culture tried to start, it has to go one step higher. We also have to also ban companies that do abusive practices. For example, that will hire someone rather than pay the local prevailing compensation because that person will work um, according to a lower quality of life, which most people in the country could not survive on. So there's going to be a social and moral compact. Um, and with the Kanecki operating system, it's also going to be that it's going to be made so you don't have to have a lot of memory on your smartphone, and you don't have, and it's going to be made simple. So basically, other people can play with it, try different ideas with it. Educational use is always free, and you don't have to be an educational institution to qualify for educational use, which was the old basis of the computer revolution in the 70s and that. So now, before I proceed on to the next segment, I just would like us just to take a look at this one last time. This is how the old CPM operating system was in bootloader application program area, CCP, which is where the commands were processed. BDOS, which is basic disk operating system, which is where information was, where subroutines existed, where you could write data to disk, read data from a disk. BIOS, which was a direct linkage to chips on the computer that did certain functions, like that controlled the video, that controlled the disk drive. Those were the functions that controlled those chips. And then the mirror area, which allowed a greater application program to be done. So I'm planning to get an open source project started on this, and I'll post a link. But take a look at this, most of my ideas around. Let me know what you think on Twitter at Diana18. Now I'll just stop temporarily just to move on to the next segment. Hello. I'd like to continue in the next segment where I talk about app development a little bit further. Now, this is going to be different compared to what maybe some of you are used to, because um, when we thought of app development or program development, as we called it back then, we used visualization, we used mind maps, but we used them in a different way, though. In some ways, which is similar today, but slightly different. The primary thing was it wasn't so much as to what you think about, like with UML, where you have the box, you have the function name, you have the procedures, and then you have the variables. It was more, think of it as like a painting. Um, that basically, before we even got to that phase, we did the painting. And just to give an example, this is an application, a program that I developed, is also as part of an independent study to Kanecki Prolog. And Kanecki Prolog is based upon the idea that with with information you have it linked. And what I did is I used Kanecki Prolog to sort of solve some ideas in Prolog, but at the time I couldn't find a Prolog that would run on my Osborne one, so I thought of a good challenge is to write my own Prolog interpreter. And so what I did was I wrote my Prolog interpreter, but not really understanding Prolog as fully as I do now. I actually wrote it with an inverted list where basically the items, instead of the list with the arrows going down, items point up. So like, for example, here K equals ABC, then it goes ABC goes C points to B, B points to A, and then K equals AE, which means E points to A. Now, someone may say, well, what is the advantage of doing this backwards, or doing this strangely? Well, it's interesting because the reason that this is done with an inverted list, what it actually allows for database solving and easier database linking. So that actually you could find information sooner and you could do things better. That and the way I demonstrate this as I use certain concepts, I showed certain concepts, and actually I was able to get it to run on an Osborne one. And the thing is, what happened though is with it I was able to use this to also find a solution to certain cancer genes by basically downloading a database and actually coding it into my Kanecki Prolog format, which I call the program cancer uh, cancer emulation solver CES1, which allowed the program to find, like, if someone wanted a certain cancer gene, find out what's the pathway from this cancer gene to this cancer gene. Well, all they had to do was actually, let me just show you on the board. All they had to write on the board was this expression K. For example, NEU1 is one cancer is the starting cancer gene, and KEU is any cancer gene with the question mark. And what the program would do is the program would make a list as to what the pathway was, and also it would find alternative pathways due to the inverted list. This did it quickly, and also this program was test marketed, and it did get a good initial response. I'm still working on doing full marketing of it. I do have it on sale on my website at Kanecki, Kanecki .webs.com. But just remember Kanecki, Kanecki.webs.com. And the thing is, this was an idea I did. It wasn't necessary for money. It wasn't for making money or anything else. It's just an idea. I wanted to try something, see what happens, see what you can do with it, play with it a little bit, and because at the time I was studying artificial intelligence, and this was an interesting artificial intelligence project. Whenever you study a project, it is important to have fun with it. I mean, if you're not going to have fun with it, why do it? I mean, really. And also, when you do a project, what I did, most of my projects were done as what's called a master programmer basis. Sometimes some projects you have to do you can't do in a master programmer basis because it's too big. So this was a nice entrance and segue into our next segment. So let me pause for just a moment and get the slide prepared for the next segment. Oh, hello. Now I'd like to start the next segment. This next segment is about on the development process. Many of my programs were developed, excuse me, were developed as what some people call the master programming model. And what the master programming model is, it goes back to it's a culture like where you have a master workman or workwoman. Basically, they do the whole project themselves. They design, fabricate, build, and or or they may train an apprentice that works on certain parts of it, but they still do all the processes themselves. Now, when a project gets too big, then it goes into either the assembly line process or the team process. And what I prefer is I prefer the team process. I'm not I'll say it, I'm not a fan of extreme programming. The reason why I'm not a fan of extreme programming, even though you have two people working together on the same code, the problem is it's not a collaborative effort. It's still, as I mentioned in other talks, about two two people, one person playing against the other, and the one that's deemed like the best player gets the spoils. And again, it's a spoils system. And that's why I'm not a fan of extreme programming. That's why I prefer the team programming approaches is what was discussed in Slackware 95 and used in open source today, as well as other ideas. And what I like to do is give an example visually of what I mean by what I'm talking about. In the master programming segment, you have a person who has an idea. She likes the code and does it all herself. And the reason why I use the she is because even though STEM is just starting to sort of be realized, actually the first computer programmer was a woman by the name of Ada Lovelace. And the person who wrote the code for the command module was also a woman who wrote 27,000 lines of code that helped the Apollo program land on the moon in 1969. When I first studied computer science, there were more women in computer science, and I think partially it was due to the era, partially it's due to the rejuvenation that you can do things, and it was also partially due to like the Republican ideas, but also responsible liberal ideas and responsible feminist ideas, as exemplified by Madonna and Cyndi Lauper and others. That you can succeed on your own. You don't have to go through the old boy network. You don't have to be a girl band. You can be your own. You can, and like Madonna formed her own company, and but now there aren't as many women, but there should be because the problem is when there aren't enough women present in an organization that develops or is creative, it does become like a frat house, and a very bad one at that. Whatever you saw in the movies, think worse. I mean, it may look fun in the movies, but if you had to go, but you have to work in that environment every day, and you're a woman, and or even if you're a sensitive guy, no. That's why a lot of people leave the field and try to form the companies outside of the valley now, rather than in the valley, because that's part of the reason why I am still in the Midwest. I'm still trying to do it without venture capital, still trying to do it organically and step by step. because I don't like the frat boy atmosphere. Um, but getting back on topic, the master programmer writes the code as the code themselves. Now, when there's a team, there's a person who has an idea, and they start writing a skeleton, and then they put the skeleton out there, and there are other people who pick up ideas like different parts, and they coordinate the parts together. However, the thing is, they're not competing against each other directly or indirectly, and also they're not passive aggressive as what exists in extreme programming. They are working together. The point is, it's a creative environment, not a passive aggressive environment. And the reason why that word passive aggressive is important, because when people work in an environment that is that looks like this but is passive aggressive, what they will do is they'll eventually go back and going into a master programmer, because they have creativity, want to do things, but they don't want to deal with all the drama. They don't want to deal with all the games. I mean, yes, everyone has problems. Everyone has daily issues. I mean, I have an issue right now. This is my 110th day that I've been homeless due to domestic violence, but I'm still getting out each day doing things. Um, but the thing is, no one wants someone that's going to come and attack them because they were attacked by someone else. Because in a passive aggressive environment, when people are attacked, they'll pass the hurt forward, and that's why people eventually go and become a master programmer. Or what they'll do is they'll go on open source and join a team online rather than work in an extreme programming environment in a in a in a cubicle or something else. Because my favorite person that I like is that sort of helped me quite a bit to break away is the founder of Dilbert. The reason why is because around I'm probably going to date myself. Around 92, I worked as a medical researcher. This was during the Operation Desert Storm, Desert Shield period, and I was glad to do my support, and we were glad to do our support for the Navy in providing blood products and helping troops. However, um, the thing is, like most people discover, when something becomes too much money becomes infused in too much politics, the corruption starts coming in as well as the games. And that's when around 92, I started reading Dilbert and realized, well, wait, I don't have to deal with these games. Neither did the founder Dilbert. He rather than complain, he did something about it. He left the cubicle a long time ago, and I left the cubicle because actually my lab was like a cubicle is a 10-foot by 10-foot space, packed with medical equipment and a little bit like a dark room. So that's why I'm used to working in 10-foot by 10-foot or 10 by 20 spaces. And my parents were happy that I did, because it means that they were afraid that I was going to be dragged in to the passive aggressive environment, to the corporate environment, to stepping on people, to stepping on people's backs, to playing people, to making off their friends, to report them to others. I mean, all of us have been through this. And and the thing is, I mean, some people say, well, you're not going to make as much money. You're not okay. Well, the thing is, what's more important, you as a person, or you still having a good quality of life? I mean, I still have a good quality of life. I still can be creative, but also I've been true to my values. Um, in app development, who you are as a person also does influence your development process and the app process, because if someone's app thinking process is all like, well, what can they take? What subroutine can they sort of coerce out someone by being their friend or something else? Well, they're not really creating, they're pasting. And the thing is, eventually, when someone becomes known as like a stealer or paster, eventually people get the word out. Well, they'll say, well, hi, hello, but they'll be careful not to share things, because they know that this person's going to try to take something that's and claim it's theirs when it's not. And But if someone has a creative attitude and a good attitude, where they're not passive aggressive, they're not walking on people, they're not stepping on people, they're not playing people to get information, report to someone else. Um, um, then when they get an idea, they may not know exactly how to do it first. And this is a cliche, as mentioned in The Secret as well, um, by Bob Proctor and others, and Bob Vitale. The thing is, you will figure it out. You will figure it out, and it'll be a fun process. You'll be able to do it. You'll be able to solve it, and it is important to realize that um, we need to work together to do this, because solving things in the process does make the world better. Now, in the next segment, I will um, give you information as to how to contact me via open source to start on the Kanecki operating system project.